Hi, I'm Leah Bergeson from the University of Alaska Fairbanks, and this is Alaska Voices. I'm joined by Scott Rupp, who is the director of the International Arctic Research Center and principal investigator with the Alaska Climate Adaptation Science Center. Scott is also one of the founders of the Scenarios Network for Alaska and Arctic Planning, or SNAP. So Scott, welcome.
Thanks, Leah. It's nice to be here.
Today we're talking about community and wildfire. Can you tell me what that means to you?
Yeah, it means a lot. So my background is in forest ecology, but I've really been fascinated by wildfire ever since I was an undergraduate in college. And since coming to Alaska in 1993, I've studied wildfire. I've built computer simulation models to look at the interaction between fire and climate. Beyond the science, as I lived here in Fairbanks, I saw a very evolving issue of wildfire and the impacts on the Fairbanks community. When I first came here, the idea of a smoky summer was more of an anomaly than almost an annual event. The idea of parts of Fairbanks being evacuated was not something that we were experiencing at that time. And so that has a lot of consequences for people, both in terms of their personal safety, but just health impacts of smoke and just how it changes the dynamics of people's comfort level with living in this wildland urban interface. And so it's really been interesting to see that evolve, but also see the firefighting and suppression technologies evolve, but also the science evolve in terms of how we're working to understand these changes and the impacts on communities. And then particularly here at the International Arctic Research Center, we do a lot of work with groups like SNAP and the Alaska CASC of trying to figure out how we can turn that research into actionable science in ways that people can make better decisions.
I'm looking forward to hearing what you have to add, because it sounds like you've been thinking about this for a long time. So with that, let's get into our first conversation between Trisha Hutton and Jacob Coffey. Trisha is a master's student in Earth Systems Science who is developing high-resolution climate scenarios for Alaska. And Jacob has since graduated from his master's degree in atmospheric sciences after defending his thesis on climatology, seasonality, and extremes of fires in Alaska's boreal and tundra regions. I got to record this conversation and listen to these two talk just before Jacob graduated. There was spring energy in the air, they were excited for the sun to come out, and they were also just thrilled about the work that they were doing. This episode was titled, Deciphering the Many Facets of Weather.
My name is Trisha Hutton. I am 25 years old. I'm currently living here in Fairbanks, Alaska, but I was born and raised in Rochester, New York. And today I'm here with my friend and fellow graduate student, Jacob.
Hello, my name is Jacob Coffey. I'm 24. I currently live in Fairbanks and am from Patchogue, New York. And I'm here with my fellow graduate student and friend, Trisha.
So I'm a background in meteorology and atmospheric science, also earth sciences. And I'm continuing my master's degree right now in Earth System Science with a focus in atmospheric and climate sciences, where my background was in meteorology, but now I'm much more of the modeling focus.
My undergraduate was a mix of meteorology and climatology for my classes, and I graduated with a bachelor's in meteorology. Then coming here, I'm using the meteorological knowledge and kind of adapting it to a more broad view of it, to where I use some modeling data, but don't do direct modeling like you do.
Yeah, so we have two unique perspectives where you are right now doing your research for your master's with the model data, and my research currently is almost producing a model.
How do you feel about being in Alaska doing research?
Oh my gosh, it was a dream to come here. This was my dream school. This was my dream education. And the research we do is incredible. It's so necessary with us already experiencing changes in the climate and the different variability we experience. We also have our undergraduate program starting here. I'm excited to have undergrads with us. And my undergrad didn't have graduate students at the same school. But what about you? You're wrapping up your master's.
I feel incredibly lucky. to have been given this opportunity from both my advisors and to gather all of the knowledge I can from the people here. I think it's been a great experience. The Alaska winters are a little rough,
No,
but
it's
like
amazing.
outside of that, it's been beautiful here. The growing season is definitely my favorite though.
Unless you live here, I feel like people forget that we could have fire seasons. I thought, okay, fire weather. Like, I didn't really think that it was such a big atmospheric science or meteorology topic.
I was surprised how much went into it because coming from New York, we didn't talk about fire. Fire wasn't a thing. We had thunderstorms, we had nor'easters that would track through, and then occasionally lake effect snow when I went to college. Come here and find out that million-acre years are pretty common, and they're dealt as like extreme years. But in more recent years, you wind up seeing more and more million acres burned. And I think 2004 was the most, and it was a couple million acres. It was more than
Just a couple
than
million.
3.
The news highlights the Canadian fires.
They don't highlight Alaska.
Yeah, they don't. And we have the same tundra and we have similar vegetation, but I feel like people don't know about it.
Yeah, until it impacts a like populated area, it doesn't get a lot of coverage. Even the Canadian fires got coverage for like a day or two, and then 3 days later, it was like nothing happened. My work has been on the top level of fuel because we've been seeing more fires out of the boreal forest, and you wind up having these fast, widespread fires. So I've been looking at the index that determines the spreadability, called the initial spread index, which takes a lot of different observational values. So your precipitation, your humidity, your temperature, your wind. It's broken up into 4 subseasons based off of the main driver, that being wind-driven fires, the duff-driven fires, the drought season to where we just don't get our long-term rain because convective rain like thunderstorms will cause more fires.
Did you ever think you'd do fire research?
No, funny enough, I initially had thought I'd go out of college right into work. I thought I'd do a lot of watches and warnings calculations.
I know a lot of people in our field are like, I knew I wanted to be a meteorologist since I was a little kid. Were you one of those? No.
No. So I initially wanted to make video games, and then I was terrible at coding.
But you still have to code all the time here.
Correct, but it's not to the extent I have to do for video games. When I was in early high school, I realized I didn't want to do video games anymore, and I didn't know what to do. And I had an earth science teacher who kind of made me gravitate towards just a love of science. When you go into meteorology, you'll find people that are there for either just the credits or they tap out when they find calculus.
And all the physics. It's a heavy degree.
But I grew up in Florida, and we had gotten our fair share of hurricanes for like the 7 years I lived there.
I think personal impact, a lot of people have stories of like when we experience this tornado or flooding or something like that, that it's a very like heartfelt and impactful scenario that then we want to further understand or better our community with it.
What about you? What drove you to the field? Were you always just looking at the clouds?
I was always looking at the clouds, but I never connected the love for meteorology or the idea to study it until much later. I had no idea what I wanted other than the fact that I wanted to help people. I thought maybe nursing, teaching, social work, physical therapy. I literally switched my major so many times because I was so indecisive. And I took a random geography class to learn where different countries are that I would want to go travel to one day. It's so embarrassing. And after taking this class, we learned about large-scale atmospheric circulations like the Hadley cells and things like that. And I fell in love with it. And it was at community college back in New York. And I was just like, whoa, whatever this is, how can I make this my life?
After this is all said and done, what do you want to explore in Alaska?
I want to look at rain on snow events across Alaska, which is becoming more frequent when we already have some cool temperatures and snow is on the ground. And then we have a warming period and we have rain falling. We had, Ice-mageddon a few years ago before I moved here.
Before I came here, we had Ice-mageddon.
Before I moved here. And a lot of moose died from it. So there's a lot of different impacts on it.
I didn't know there was wildlife deaths that were recorded for that. That's interesting.
Yeah, so there's transportation impacts, there's plane and cargo impacts, but there's also, if we get enough rain that then freezes, it can actually hurt the plants that the animals are trying to eat if it's covered in all this ice. Our field is so interdisciplinary. Like, you can't study fire weather without knowing the buildup in the vegetation vegetation, and you can't do rain on snow events without knowing all the other aspects of the hydrology and other impacts of it.
And the weirdest bit is permafrost.
I was going to say something about permafrost.
Especially on this topic, because permafrost currently, if you're in a continuous area, you don't have interaction with the soil and the water. Mm-hmm. So it just kind of pools at the top.
And this is a very nerdy sentence, but I think about permafrost a lot. There's just so much. It's such a complex system that you always need to...
You can never get it all, especially when you're doing future modeling. You can't predict every variable and how it's going to change. And that's the really difficult aspect.
Especially up here when it's so niche in such remote places, have such different hazards and impacts that you just cannot cover everything.
And I think coming here, doing fire weather, and through going to like a conference or two or through talking to people, there's a lot of connection to fire or just to weather. And that's the one thing that surprised me, is just how much of a connection people can tie to just experiences with weather or just weather as a whole. I did realize very early on when I was finding out what you can do with this is my end goal was to help people, which is why I didn't immediately gravitate towards graduate work at first. And now doing graduate work, it's been helpful to kind of...
Because it builds you up more to then go out into the field to help people in the future.
You can feel the excitement of these graduate students. The same thing happened to me when I came here to do my PhD in 1993. Was Alaska's just, it's such a big place. Everything's big. The mountains are big. Fire is big. And having the ability to learn these technical skills in a place like this versus looking at it from the outside, it just really changes how people go about doing their science. And I think increases for a lot of people their commitment to wanting to do more than just publish a scientific paper. They want their work to be relevant and useful to people.
Part of their conversation that sticks with me is this idea of personal impact leading them both to meteorology. And I think that that's true for a lot of people that go into the sciences. What brought you into ecology to begin with?
Like Jacob and Trish, I grew up on the East Coast in Southeast Pennsylvania. Wildfire was just not something that you thought about. So the way I came into it, I started learning about how wildfire is an integral natural component of certain forests in the Western U.S. And I was fascinated by how trees had adapted to not only survive fire, but utilize fire to increase their progeny. And luckily, somebody who's long gone from UAF now, but Keith Van Cleve came across my radar and I ended up getting connected. Lo and behold, I ended up here doing my graduate work.
Do you see any differences between the way ecologists and meteorologists approach earth sciences?
Maybe ecologists are thinking more of the system as a whole, and you're almost immersed in that system and observing, where a lot of meteorology, and particularly when you get into atmospheric sciences and the sorts of things that both Trish and Jacob are doing, is you're really looking at things from a mathematical standpoint and trying to get those equations and algorithms just right so that you can make accurate projections into the future.
Maybe that's part of the magic of what you guys do, bringing ecologists and meteorologists and other disciplines together to work on these solutions. And it's interesting that you mentioned immersion, because while I hear that for Trisha and Jacob, they're both excited to be here, to be immersed, to learn about this place as they're modeling it. I'm curious if you remember the Yankovich fire. Were you around for that?
I was walking on campus on a Zoom call and I was trying to get some steps in. And during fire season, I'm like a wildfire geek and I'm always looking at what's going on. And I know helicopters and airplanes, and I can just sense when that's just not a normal helicopter. And so I was walking and I quickly was like, oh, there's a fire. And then I realized, oh, there's a fire really close.
The Yankovich fire occurred on the afternoon of July 16th, 2021, on the northern edge of the Fairbanks campus, just a short distance away from dozens of houses.
By the time I got back here to IARC, I sort of stood out here along the side on the lawn with a few other people and watched the really amazing aerial display of suppression efforts that went into that fire and the kind of efforts that you need to squash something like that when it's so close to the built environment and all the houses that were here.
Mary Burtness and Jeff Adams also had a front row seat. This conversation is entitled Wildfire Wisdom Under Cathedral Trees and was recorded by Jesse Robertson.
My name is Mary Burtness. I'm 68 years old, and I'm here talking with my husband, Jeff.
And my name is Jeff Adams. I'm age 70. We're at UAF, and I'm speaking with my partner, Mary. I was in the yard, I think it was like 10 a.m. in the morning or so. First, I noticed a helicopter flying around, which is not that unusual. We're kind of in the flight path of the airport. And then a runner came by and said, "Hey, mister, there's smoke down the trail." She came back like about 30 seconds later and said, "Hey, mister, there's flames down on the trail." I started packing up like our firebox that we have the important documents in and some photos and some of those things and put them in the truck all ready to go in case things really started getting hot. I felt somewhat comfortable, though, because the smoke wasn't coming our way, so I figured wherever the fire was, it was probably moving more or less away from us. Then must have been half an hour maybe after that, an hour. Then all of a sudden there were like 3 helicopters, and then there were 2 big scooper planes that showed up. And then I figured this was much bigger than what I had assumed it was. Then I could see firefighters coming down the trail with all their equipment on. So I talked to them. They seemed very calm about it. So then I just walked down with them to where they started actually removing the duff and getting down to the mineral soil. And I just watched them for a while and then actually got soaked a couple times with scooper planes. Anyway, I could see they had it under control pretty much. It wasn't that big a fire. But just to see those youngsters working like that, it's like, boy, they really work hard. They have all the respect in the world for those folks.
I was riding my bike back home, and I saw a helicopter go over with a bucket. And I thought, oh, there's a fire somewhere. And I could kind of see smoke and thought, oh, it seems pretty close to town. And then I come up on Yankovich, and all of a sudden there's people outside, and they don't quite know where the fire is, but can kind of see the smoke, and there's a trooper there. And then I watched a fire truck go into our driveway. So I called my husband twice, I think, and he didn't pick up, which is not unusual for you. But the trooper was really wonderful, calming me down and saying, no, you need to wait here, you need to wait here. Finally, he let me through because I had no idea what I was riding my bike to. When I got home, and then Jeff filled me in on everything that was going on, and we walked down the trail too and could see the smoke and lots of firefighters wandering around. And then we sat on our porch and just sat there and watched the planes go over with buckets of water and watching them dump, as much as we can see through our cathedral of white spruce. And we also found out earlier that day that the Forest Service was actually working with the UAF firefighter department doing some training. So that's why they ended up on the fire so fast. And all the bucket planes and the helicopter happened to be in town. And then it was kind of in the flight path too, because a small airplane saw the smoke right away.
We were very fortunate because it was calm, relatively calm. It was a lull in the fire season. There were lots of firefighters in town, and all the aircraft were in town. And so, they were on it so quickly. It was really impressive to see the response.
I don't know if they ever found out how the fire started, because it's really in a very wet area. I mean, you'd have to be wearing rubber boots at that time of the year to walk through that area, parts of it.
Where we live now, it's the deepest, darkest part of the white spruce and some black spruce too on the UAF ski trails. So we walk to Smith Lake several times a month or so, and you can just see the water level on that fluctuate. That the sedges that along the edge of the lake are now been replaced by grasses, drier species. The lake is not near as big as it used to be. Just anecdotal, but at least from what I've noticed. The sphagnum, the mosses and everything, those are always seem like they're crispy the whole summer, where in the past they seem like they were more spongy, if you will.
We first rented the house that we're in right now, rented it, and then we bought it in 1987. So we just moved back to that property, and you can see all the aspen or the poplars starting to fall over because they're getting pretty old, and it's mostly spruce now.
The snow, I think, has been different too the last couple of years or so, and so it's heavier, it's more icy, it's more glued, if you will, to the spruce. So there's a lot of trees that are bent over, several years ago when we had that kind of rain on snow event. And so it was so warm out. It was 34 degrees or so. Mary and I decided to take a walk in the evening at dark with umbrellas. And as we're walking around, we could hear the tops of all these trees snapping off. So it was just like the woods was full of this popping sound that had never happened before in all the years that we'd lived in the state.
We call them our cathedral trees. I don't think they grew up to have this much wind, so you hear them snapping during wind events too. And it's warmer. It's much warmer. We don't have those 40 below for a week at a time anymore.
The tops of spruce trees spread throughout all our property and all through the arboretum. We try to keep on top of that, at least close to the house, cut that up for firewood and then haul away the branches and everything. Close to where the Yankovich fire was, it's a black spruce area, and there's not only deadfall, but then the snapped trees and such. I mean, there's no way you could even walk through there, or a moose could even get through there. It's just so thick now. It's incredible. And we've taken some steps to remove some trees, but we live in the discontinuous permafrost, so we're somewhat reluctant to take away the shade and allow the sun to come in and heat up the soil, perhaps. But with spruce bark beetle obviously on its way to town too, that'll have another effect too. So those trees that you cherish are probably going to look a little bit different in 5 or 10 years anyway. So perhaps if you just take them down now, you can help with your fire potential.
And we're also morel hunters. We checked it out, of course, but because they got on it so fast, we knew it wasn't going to be a big morel season because it didn't burn all the way down. There was still a lot of duff layer left and a lot of the greenery still left, the root systems.
But it was a boom for the three-toed woodpeckers. Some grub, some beetle, maybe an engraver beetle, sets up their galleries in the lower part of the trees that had been burned, so you could always see how that lower part of that tree, the blackened bark, had all been picked off, if you will. And every time we would see any bird working that, it was always one of the three-toed woodpeckers. And they're not rare in our neighborhood, but I mean, they're a little bit uncommon, so that was pretty neat the next summer to be able to go there and almost every time see one or two three-toads working the standing dead trees. Anyone now that would move to town, depending on, well, regardless of what your water source is, to try to have some sort of reservoir. And think about what it would take to actually get that water onto a fire someplace, to at least be able to, in theory, wet down your roof, and so that you could delay any type of damage so that the firefighters could get there, those kind of things.
Alaska Division of Forestry and Fire Protection has a program called Firewise House, and they have pamphlets and all sorts of things. I had spent time during COVID to clean out the front, all the small branches, all the bottom stuff. And I keep looking to the east thinking we really should do it that way, because to the west is our parking lot, but to the east it gets pretty close. So we wouldn't want to cut down trees, but at least cut down the lower branches and get rid of some of the deadfall. But every year I think that, and I haven't done it yet.
And then the mosquitoes come out, yeah.
Yeah, true.
It makes it harder to get out into the woods then, for sure.
Wow, that sounds harrowing. And I know that you've been through something similar. Did anything resonate with you?
Yeah. In 2013, there was a much different fire in terms of size. I think it ended up being almost 90,000 acres burned out. Chena Hot Springs out where we live. In that case, the community of Pleasant Valley and part of Two Rivers was actually evacuated. And it was a multi-week event, pretty much from the start of it until when the firefighters actually went away. But in similar, even though we got evacuated, I personally was feeling very confident that, our house is going to be okay. And I also, having done a lot of research and working with people at Division of Forestry and Alaska Fire Service, I understood just how good they are at what they're doing. The other thing that just resonated with me was that they're just such super observant people. And I think that's another really cool thing about Fairbanksans is, for the most part, everybody's like out and about doing stuff. They're very in touch with the outside world and really observant. You don't have to be an ecologist to have all these insights, and particularly for people that have been here for decades. And, you have a front row seat, not just to fires, but to this long, slow change of the environment and the atmosphere. And it's kind of amazing to just be able to witness it.
Yeah, they talked a lot about changes to the forest that's happening around them, including it may be drying, the lake getting smaller, spruce bark beetles on the way. As a forest ecologist, do you find yourself making note of all of those things in your own daily life around your house? And also, do you have any insights into anything that they were talking about?
Yeah, absolutely. I mean, I do the same thing. We've got a pretty big property and we do a lot of walking on trails, both on and off our property. And I'm definitely always taking notes of things and observing changes. Some of the observations that Jeff was making, that's not unique to his backyard. Those are the things that are changing in terms of how dried out the duff, the moss layers are getting in particular years. Changes in the composition of the forest in terms of, what species are there, which are breaking down, and things like spruce bark beetle and the potential impacts that has on fuel availability for fires and just otherwise changing the dynamics of the forest. So those observations are very much in line with what we see happening throughout interior Alaska. And they remarked about how it's getting warmer, and that's very much certainly the case. Even in a year like we've just experienced when we had a super cold winter, overall, I think 2025 was one of the warmer years on record, even with our cold winter.
Yeah, that's a great segue to our next conversation, which is between two programmers for the Scenarios Network for Alaska and Arctic Planning, who look at things like what will the temperatures be like in 10, 20, 50, 100 years, and how are those changes impacting all of the life around us. So this next conversation is between Charlie Parr and Josh Paul and is called Translating and Curating Climate Data for Everyday Use.
My name is Charlie Parr, and I'm a geospatial data guru, programmer, scientist person at the University of Alaska Fairbanks. I'm from Fairbanks, Alaska. I'm here today with my colleague, Josh.
I'm Josh Paul. I'm also a programmer, primarily with geospatial data. Work for Scenarios Network for Arctic and Alaska Planning at UAF here. It's pretty new for me to say that I'm a programmer. I didn't used to be a programmer. I used to be a soil scientist who made maps and then started using GIS and realized, pointing and clicking my way through the processing pipeline for data is the slow way to do stuff. And so if you learn how to program the computer, tell the computer what you want to do, you can actually do a lot more and have the computer do the work for you. I think you had a pretty similar journey, Charlie, right? Like you didn't start out as a computer science programmer type guy when you got out of high school and decided to start a career, right?
Yeah, that's correct. My undergraduate degree is in geography. And in that experience, I used a lot of GIS software. Someone told me, if you really want to sort of own your geospatial situation, specifically learn to program in Python. And that was probably around 2013 or 2014. I got a job working as a snow scientist, which is like being a soil scientist, probably. There's probably shovels involved.
Soil that melts.
There you go. Yeah. and its water content is 100%.
Shovels involved. Yeah. This is common. This is a common way to get into programming. Kind of sucks people in, I think, from different disciplines where you have a problem to solve and you realize, man, I need to learn a programming language to do this or else it's going to take me forever. Or it's just an impossible problem to solve without a programming language. Then you start programming and then all of a sudden you kind of leave your field that you started in and you're a programmer. And then you can work in a bunch of different fields, really. You can help out scientists from all sorts of different disciplines because you know how to speak the language of data.
To your point, yeah, I think it's also a good way to learn because you have a problem that you're trying to solve. I think it would have been difficult for me to just learn programming or get my start in programming in sort of an abstract or academic way. I think having a very real world science type of objective that I was trying to accomplish really motivated me and made it interesting and engaging for me to learn. Josh, question. Are you a climate modeler?
No, absolutely not. I don't make the models. I don't know a lot about climate science, like atmospheric sciences. I'm more of like a data wrangler, trying to take those modeling products and do things with them. What about you?
Same. We're not climate modelers. We work with climate data. We do a lot of things to streamline access and distill it and make it more accessible to people. There are dozens, if not hundreds, of different climate models that are available throughout the world. And all these climate models have maybe different assumptions about how certain types of atmospheric physics work. And then, of course, you can have sort of different assumptions built into the climate models about how humans are likely to function in the future and contribute or not contribute greenhouse gases to the atmosphere and what those feedbacks might be like in the climate system. We call those scenarios generally. So there's many, many different climate models, different emission scenarios, but luckily there's some global cooperation to create experiments where you take a bunch of different climate models and give them the same set of inputs and see what happens.
We throw around a lot of acronyms, and one of them is CMIP, but this is the Coupled Model Intercomparison Project. The group that runs the CMIP project was able to kind of put out this call and say, we're doing this project. These are the parameters. And then all the modeling groups all over the globe use those same parameters to do their own modeling experiments. And then you can compare them apples to apples. And it's incredible that it happens at all.
And that allows people to compare results across all these different models. And then you can start to determine for your geographic area, say Alaska or the Arctic, what are the most skilled models for predicting things like sea surface temperature or sea level pressure or temperature or precipitation or whatever variable you might be interested in. Which of those big group of models do the best? And then we also sort of distill this into easy to get packages of data that researchers could grab and use for their research, or people that are writing grants or community members could then get this information, get some context around it, and be able to use climate change information in their work.
In a word, we'd say that's curation. I mean, you could be a highly decorated PhD in a very specific field like biology or something, and you want to use climate data in your work, but that's not really your specialty. You're used to, you're counting newts or something. And so having some support staff, science support staff like us, like in between the kind of hard to parse climate data and your discipline. As a scientist, we do that sort of work all the time. We have a little bit of experience in the field. And so this isn't just data. It's not just numbers. We know it's actually trying to represent something real on the ground that we may have experienced or have a little bit of real life experience of. And that's super helpful. If you were just purely a programmer and had never actually been afield in Alaska and you're dealing with all this Alaska data, you might not realize when some values are maybe unrealistic or wrong, without running it by an expert. It wasn't long ago, we were looking at some projected precipitation, and there were some pixels in Southeast Alaska that were like kind of a bonkers number, like 500 inches of rain a year. And we're just like, is that realistic? Like, is that okay for the model to predict that? The models aren't perfect and they're like global models. And so are the values going to be realistic everywhere? Like, maybe not. Maybe the modeling at the top of Denali is going to be a little weird because it's just like a pretty extreme place on the globe.
We also do something that's called downscaling, which is bring those models from a really coarse resolution where maybe you have one prediction for every 1 by 1 degree square of latitude and longitude to something like, okay, now you have a prediction for every square kilometer.
I think a lot of people don't realize how many people are doing this. The level of cooperation that happens is pretty amazing.
It really underscores how important climate is as like a prime driver of all of our human activities. Climate really determines where people live and types of industries we engage in and how we recreate in our culture and our food and our agriculture. And so climate, to me, I really view it as like a prime driver of life on Earth, really, not just human life, of course, but, plant and animal life as well. And so I think that's why there's such incredible international cooperation to try to get a glimpse of what some climate futures might be that are ahead of us. Sometimes you see it written or it said that, weather and climate is this unpredictable thing. And it's not. We actually predict both weather and climate all the time with a lot of skill. We do it really well, but there are some limits to how credibly we can do that. And certainly the further out you go in time, the less certain you can become. And figuring out how to make sense of those predictions and projections and models is a lot of work, but at Snap, if you live in Alaska or in the Arctic, like we've done a lot of that hard work for you already. Sometimes we might make something that's a little bit more technical for engineers. We have a tool, the Arctic EDS, arcticeds.org, and sometimes it's for, researchers, which is the case of the Arctic Data Collaborative, arcticdatascience.org. So we have different tools for different users, and we have web applications, that people can use to get a handle on, how a changing climate might impact where they live or the places they care about or what they do for work or where they recreate.
Especially Northern Climate Reports.
Yeah,
that one, we're
hitter.
talking a lot about data and numbers and stuff, but that tool gives plain language summaries of how a bunch of different climate factors are predicted to change in the next 100 years or so. That's northernclimatereports.org.
Yeah, I would encourage people to not despair in this prospect of an unknowable climate future. We have tools, good tools to get an idea of what might be coming. And of course, we hope that people can use that then to plan and prepare and adapt and navigate whatever's going to come our way from a climate perspective with more skill than would otherwise be possible.
I just love listening to them geek out on what they do with data. You can tell that they really enjoy what they're doing, and I know for a fact that they're really good at it. Climate and climate change, it's very complex. It's also extremely data intense and data heavy. And we now live in an age where we have the capacity to run extremely complex models over very large areas and produce billions and billions of bits of data. That is exciting, but it also provides a challenge to even researchers in how to utilize all that information and actually learn from it. One of the cool things about Snap, and they talk about some of the tools that they've developed, they are really focused on ways to make highly technical, massive archives of data accessible to not just researchers, but to the general public. And they work really hard at really interesting ways to distill that information down, not only accessible, but understandable to a wide range of people.
You are a now self-proclaimed fire nerd, and that's how you spent a large part of your career, not just as a fire nerd, but as a fire researcher. Partway through, you realized that this accessible community level climate data was something that was really needed. Can you talk about how that came up for you as a researcher and what that process was like to try to get that data?
Yeah, I think there was sort of two threads that we worked upon. One, just from a scientific perspective, it's really important to be able to reproduce your work. And since we were working with large data sets, and many times we were modeling future conditions, whether it's future wildfire, or future vegetation distribution, or future climate. And it's really important to be able to well document exactly how you did that so that people like Charlie and Josh can reproduce essentially what you've done. That's sort of the gold standard of science, right? The other thing that happened, particularly for me, as I started working very closely with fire managers and the agencies here in Fairbanks, they really need places that they can go and get quick summaries of what's going on and how they can pull that information.
Our next episode, we're going to hear from two other researchers that work really closely with managers, farmers, all sorts of people in the community. And that conversation is between Nancy Fresco and Chris Weigel, also two other scientists at the International Arctic Research Center. So this conversation is called Navigating the Last Mile to Deliver Research Results. I recorded this conversation and Kel Skonberg edited.
I'm Nancy Fresco, and I'm a research associate professor at UAF, and I'm here talking with my colleague Chris. Oh, and I'm 52 years old.
Yeah, hi, I'm Chris Weigel. I am a researcher also, and I'm 55 years old.
Yeah, we have not actually worked closely together, but we have a lot of overlap, I think, in our research. I mostly work on climate change issues, but all my background was in ecology and forestry, and I got pulled in way back when the research group Scenarios Network for Alaska and Arctic Planning started up in 2007. So that's when I started down the slippery slope of doing climate change research.
I'm German. I grew up in Germany. And at one point, I wanted to be a theoretical physicist. I studied physics. I got a degree in physics. And I was in France for a while. But then I dropped out of grad school. I taught. And I ended up in the software industry. And I did web tools and web development. And it was only in 2011 when I came to Alaska that I really fell in love with the place. I started as staff. I was doing software development here first. And I did a PhD in remote sensing, specializing on wildfire, because I saw how important wildfire is in the north. And with the background in physics and experience handling big data and computationally doing analysis on it, remote sensing seemed like a great fit.
Working, trying to make sense of big data, trying to make sense of climate change, trying to make sense of what's happening with fire in the boreal forest. All of those are the kind of large landscape questions that require expertise from a lot of different people. And so I have no skills in making online tools, but I work with other folks on the SNAP research team who do. So yeah, your background and your trajectory are completely different from mine, and yet we've ended up in kind of a similar place.
Isn't that such an Alaskan thing? You meet all these people here with different trajectories and you find so much overlap. You know, when I lived in big city, I lived in London, it was so hard to even meet people who did different things from me. You had to go into an organized environment with some sort of organized group. But here, it's one of the attractions of working on Arctic topics too. I think it's much more common also in other parts of the Arctic that there are not so many people. The people who are here have needs that other people don't understand, but we understand each other's needs.
Yeah.
One of the things that was really a formative moment for me was that I got to attend the spring and fall workshops of the Alaska Fire Service. And as a scientist driven by, we want to create knowledge, we want to find something out, we want to say, oh, this is how fire behaves or has changed or will change, or these are the factors that drive some behavior, or here's a map of something related to fire, where it is, where it was, how severe it was, where it's going to be. So we often say, okay, our work is done. I've created the knowledge. I've published a paper. Bang, you do the rest. Well, they can't. The data is lying on some server somewhere. It's in a format that they've never used. The GIS manager has already a lot of stuff to do. So really working with them and listening very closely what they actually need, and then going this last mile, figuring out how to connect this endpoint of the science with the input point of the use of the science. That's so attractive to me. And since I worked in the software industry where usability is a big topic, so I was predisposed to think about that in the context of science and scientific data.
And I think that practicality, I mean, maybe that does also tie into the Fairbanks mindset of kind of being practical, being hands-on, being do-it-yourself, build your own cabin, make your own garden, that broader mindset of things being usable and practical. I think it's something that you and I have in common, loving to do science, but really wanting to see it connect with the people who need it.
Yeah, and then I think the surprising point that comes on top of it is it makes the science better because you're talking with people who actually ask the really hard questions. If you're just always in the academic environment, then the exact question you're answering may not really go to the heart of what the practitioner on the ground sees.
Yeah, and I think the most rewarding part of my job is, even though it's challenging, is when I'm taking our climate projections and data and things that we've crunched on a computer behind a desk. And then I'm talking to people from a rural community who are actually living with the consequences of whatever change is ongoing. But the questions that are left unanswered are just as important as the ones that we might have an answer for. And I have to say, honestly, we don't have a model for that. We need a model for that. We don't have it.
And I think by working so closely with practitioners outside the academic environment, it might help counteract the influence of the doubts, the mistrust in science, because you do need to connect with people and you need to give them something where they say, oh, yeah, or work with them to create something that where they actually see that it's useful and it's helpful and you're honest and you are a partner for that.
There already is uncertainty in the existing models of what's happening now. And then you throw that into the future and you add another layer of uncertainty in terms of, well, how well are we going to manage greenhouse gas emissions decades into the future, and how will that play out on the global scale? I think people do understand that on a fundamental level because it tallies with how we live our lives. And if you're unsure about whether it's going to rain today, you still take an umbrella along in case. And people get that. I mean, people who plant gardens understand that it's like risk of last frost, not guarantee of last frost. I've had to think a lot about human understanding of planning and uncertainty and change and how adaptable people are. I mean, humans as a species, we've been incredibly adaptable. It's why we're everywhere on the planet in so many different lifestyles and ways of life. It's obviously a huge strength of humans, but the speed of change is really rapid now. And so adapting to that is hard, and adapting people's ways of thinking and making those mesh with a more formal scientific outlook can be tricky. Talking to community members, talking to people who are really struggling with weather, with climate, with risk, with hazard. It's good to be reminded that it's not just a scientific exercise, that it's real. If you're trying to predict where smoke goes, someone who has asthma or someone who has a newborn baby really cares about the answer to that, and that creating a better smoke model might really make a difference in that person's life, or helping people with planning, or even creating a model that can lend credence to someone who's trying to write a grant proposal to get some air filters for rural communities where there are no air filters and there are elders who are breathing smoke.
And it's good also to have a bit of a division of labor there. Many people I talk to, they always want to know about education around it. How can we educate our children? How can we get the skills that we can manage it with the tools we have in our offices, in our administration, in our structures, and about workforce development? How can our next generation get jobs that have to do with managing these things? And I mean, none of these are points that I'm particularly involved in, but luckily I know who is, right? Another colleague who has a project about workforce development, about firefighters from rural communities, and goes into the communities, and she and I are talking about, like, you know, who are you talking with? Who am I talking with? Can I tag along with you? What did you find out? You know, we shouldn't be just everybody for one's own going into a community and asking similar questions. We need to band together and have an exchange about that. That is a much better way of doing it than competing all the time.
When I recorded this conversation between Chris and Nancy, it surprised me that they hadn't done a lot of work together because of all that overlap that they spoke on. And it also hit me just how much collaboration is happening in this building and in the interior as a whole, the state as a whole. How many people need to be working with each other to address some of these really complex problems? And all of that seems to take a good amount of time. So anytime that I hear about these large projects, big steps that researchers like Nancy and Chris are making, it kind of makes it even more impressive.
I think it is something rather unique, not just about Fairbanks, but about the North in general. People tend to choose to live here. It's a land of extremes. Many of us are coming from somewhere else, and it ends up providing a different perspective. And I think people are just more open and willing to want to get to know each other and to work together. Officially, the fire season started April 1st. Regardless of what it looks like, something that we can all depend on is that there's a lot of passionate researchers out there that are really interested in trying to solve some of these challenges so that people can adapt. And there's no one that's more adaptable than people that live in the North, at least from my perspective. So we might have challenges ahead, but we've got a good community to work with.
Check out the Alaska Wildfire Explorer at alaskawildfires.org. There's information on where the wildfires are, air quality information, historical fire information. It's a great resource. Scott, thank you so much for talking to me today. I feel like you added a lot of context and expertise, and it was great to have you.
Yeah, thanks, Leah. This was a lot of fun. Really exciting to listen to all these great stories and discussions. So thanks for having me.
Of course. And there's more coming. In our next episode of Alaska Voices, we will focus on the theme of leadership. We'll leave you with a short preview of our conversation between Sabina Allen and Lauren Bell.
It can be a bit of a joke of like more researchers, outside researchers coming in and telling us like how to do things in our community, like that sort of thing. So it's something that you hear people discuss and talk about.
A little bit of tension, though, that I remember right off the bat in the advisory group meetings that I was really grateful to have raised, which was, great that we're thinking about common principles for this regional idea. And each of our communities across Southeast Alaska is so unique. And so we want to be careful about not applying general principles too broadly or trying to sell or communicate this idea to researchers that once you've got these principles down or once you have these specific ways of doing things, then you're covered for any community you go to in Southeast Alaska. That is not true.
Alaska Voices is a place for communities to connect through conversation. This podcast was created with support from the Alaska Climate Adaptation Science Center and was the brainchild of Jesse Young Robertson and Bob Bolton. The Alaska Cask is committed to providing regionally relevant science for Alaska's changing climate. Alaska Voices would not be possible without the efforts of an amazing group of people. Our producer and audio engineer is Kelsey Skonberg of Mossy Stone Media. The Alaska Voices team includes Micah Hahn at the University of Alaska Anchorage, and Leah Ferguson, Mike DeLue, Susanna Caldwell, Annika Ord, and Georgia Hood at the University of Alaska Fairbanks. We would also like to thank the musicians whose songs we heard today. Our theme is Arctic Evening by Marcel Dupreez. We also played Fireplace by Holizna, Something to Save and The Citadel by Kamiku, Eel by Mon Plaisir, as well as the following songs with Creative Commons Attribution licenses: Wonder Cycle by Chris Zabriskie from chriszabriskie.com, Fire Tree by Axel Tree, and Pure Water by Maiden from Free Music Archive. If you are interested in more conversations or information, please visit our website at alaskavoices.org. For Alaska Voices, I'm Leah Ferguson.